time to build our 3D scene transitions using shaders. Last week we prepared our starter project with two simple transitions, horizontally and vertically. If you are completely new to shader, I recommend you to watch this video. Now let's add more complex and customizable ones. We'll start by using our scene transition starter. Let's see what we have so far. We have a 3D scene displaying a kitchen, and when we change the mode, we have a transition between our scene 1 and our scene 2. It is the same model that we display, but for some objects, they change the color, or they even disappear and other object appears. We can change the transition speed, making it slower from one to another, and we can also change the type of transition between horizontal to vertical. And from that project, we will enhance it, add other parameters we can fine-tune, and add a lot of different transitions that will look better. First, let's enhance a bit our UI and add more parameters. Let's go to experience.jsx, find the use controls, and we will adapt it a bit. We will split it into groups. So the first one will be use controls. We will name it scene and add our controls only for the scene. So currently it's the mode. Currently we had 3 modes based on the number of modes available for the same scene, but let's also add a new one that we will name example scene to show how we can transition from one scene to one completely different scene. Let's create a second group with the existing one here. Let's name it transition settings. Let's adjust the parameter. The first one we want to display is transition, so the type of transition. Then the speed, we will rename it speed. It will be easier. So speed as transition speed. We can adapt the minimum value to be 0.1 instead, and to be more precise with a low step. Our progression target, we will move it to another control. So const progression target equal use controls, and then we will put it into a debug group because it's not related to the transition itself. Let's remove it here, and we should be good. Now we have 3 different groups. It's easier and better organized. If we change to another scene, it works, but we need to handle the example scene 1. So remember, we had here that example scene current visible false that we enabled only for an example, but we will make it conditional based on our current mode. So here we can get rid of that, and instead we will do if prev mod, because the first time it's the prev mod we are based on for this render target, is equal to example scene, render scene that current.visible is false, and we display our example scene for this render target. Else, if it's any other mode, we want to show the rendered scene. Perfect. Now we go to the second render target. We can get rid of that example here. Now we are on render target 2, and it's based on the mode. So if the mode is example scene, we render our example scene. Otherwise, we render our rendered scene. And then after this, we render our normal scene, which is the plane with the 2 textures. So we don't display any scene, we just want our plane including this scene within the texture. Let's try it. We can change between mode 1 and mode 2. And if we put the example scene, it's working correctly. Perfect. Let's go to our transition material where we will create new transitions. But first, let's adapt our uniforms. It's a good practice to name your uniform U and the name of the uniform. So let's rename all of them with U and U text to U transition. And we will add another one, U repeat. And by default, we will set it to 1. Now inside our fragment shader, we will rename them U text to U progression and U transition We also need to add our repeat one. So U repeat. And now we have a clear distinction between our uniforms here and VUV, which is a varying, and all the other variables, they won't start with U, so we know when we are interacting with a uniform. In our experience, we need to bind properly our parameters. Text become utext and utext2. Then inside our controls, here when we apply the transition, it's now U transition that we assign. We have the speed, but it's not related to the shader code. It's us that are affecting the progression. Let's add our repeat. By default, it will be 1. The minimum, we will set it to 1. The maximum to 100 and the step to 0.1. On change, we'll need to apply it to the repeat uniform of our render material. And last thing, in our use frame, where we assign the progression of our render material, now it is U progression. We also need to do it in our use effect when we change the mode. U progression is equal to 0. If we try it, we have an error because I forgot to change the fragment shader code. We only change the definitions here, but we also need to use them properly in our code. For the texture is good, and U progression here. Also the transition. Now let's give it a try. It seems it's working. Perfect. Let's make the repeat property work on our fragment shader. So instead of having one line going through the whole shader, it will generate horizontal or vertical stripes. Inside our fragment shader code, we have the uniform uRepeat here. We will apply it to make our effect repeated. What we need to do is to apply it to the correct value in horizontal and vertical mode. What we need to impact is the UV. So for uv.x, we need to multiply it by the uRepeat property. But because we want a value between 0 and 1, we need to use the modulo function, so mod, of the result of this with 1. So every time the repeated UV will go above 1, it will start over and create a repeat. We do the same for the UVY. Let's try it. We can change the mode. We have only a 1 repeat, so it's working correctly. If we change, we put 9 repeat, 9.1. It doesn't have to be too precise. We switch to 2, and we have stripes appearing instead of only one line. Let's try in vertical mode. Change the scene, and we have our vertical stripes. Now it's time to jump into more interesting effects than horizontal and vertical transition. In my previous video, I told you can get inspiration from my dissolve effect shader or the hover image transition effect, and also from the shader lesson I did. So we won't use them because you already have the shader code available to you that you can apply to those transitions. Instead, we will discover something new. To create our new effects, we will use a shader library, which is named Lygia. It is a library you can import into your project that contain a lot of useful functions to create those kind of nice effects. The documentation, unfortunately, is not the best in the world, but it's enough for what we want to do. For example, let's go to generative. It's the list of generative functions available within the library. Let's have a look at cnoise. And you have a running example with the cnoise function called from Lygia library. You can preview it on the right. So you can adjust the different parameters to see what it looks like. To use Lygia easily inside our React 3 Fiber project, we will use the library name resolve Lygia. Let's install it. Yarn add resolve-Lygia and yarn dev. Now you will be surprised how easy it works. You just have over your vertex and fragment shader to wrap them within a resolve Lygia function. So it will take the string and add the different imports it requires. Here and resolve Lygia over the fragment shader. Perfect. Now let's adjust our experience to add new transition types. It's transition settings here. We have horizontal, vertical. Let's do a both one. So we can apply horizontal and vertical at the same time. And we will add the following: FBM, cnoise, whirly, and curl. They all come from Lygia. Now let's enhance our code to handle them. So if uTransition is equal to 2, what we will need to do is to apply both of them. We already have the vertical. We will multiply them. So we have the step here. We multiply it with the other one. Now, if we change to both, we change the mode and we have both applied at the same time. It's not the most interesting one, so let's see for the others with the Lygia. The first one we want to use is FBM. So we include Lygia generative fbm.glsl. And because we wrap our function with resolve Lygia, our include will magically work. You don't have to worry about it. Inside Lygia library, let's have a look at the FBM function. It takes a vec2 as an input. We will use our UV. And let's have a look here. The output is a float. So let's change our code. If uTransition is equal to 3, it means we are in FBM mode. So instead of displaying mod of UVY, you repeat 1, 0, we will replace it with FBM of UV multiplied by uRepeat. And because the value is between -1 to 1, we need to multiply it by 0.5. So we have -0.5 to 0.5. But we want a value between 0 and 1. So we just need to add 0.5. Pretty simple. Let's try if it works. Let's switch to FBM, change the mode, and we have the nice transition. Let's adjust the repeat property, and we have way more FBM displayed. But before setting up the other transitions, let's clean a bit our code, because you can see we are doing the mix every time, and we have our custom function based on the transition. Instead, we want to create our final texture only in the end. So we'll do it after this if, and instead of using the logic here, we'll use a new variable we will name PCT. So we create float. PCT is equal to 1.0. PCT is what you will see mainly in the book of shader. So I decided to use the same name if you want to learn shaders through the book of shaders. And I think it means %. Oh, and we can also move the step within our final texture. So here. So now inside all our transitions, we will get only the logic based on the transition type. % is equal to mod of UVY multiply by uRepeat. Same here. It will multiply both mode. It will change the effect here, but it's not a big deal because we don't care a lot about the both and the effect will look nice. And PCT is equal at FBM. Let's try it again. Our transitions are still working. And you can see now the effect is different when we use the both. But I even prefer this one. And our code is way cleaner. We now separated the logic of the transition and the apply of the texture mix. The more we will add type of transition, the easier it will get. Let's add the other ones. We have 4, which is for C noise. We have 5, which is for whirly. And we have 6 for curl. Let's remove the spaces here. Let's go higher and do the Lygia import. So it's the same logic. You just go to the documentation and find how it works. For most of them, it's the same logic. C noise of UV multiplied by repeat. Whirly of UV multiplied by uRepeat. And there's a slight difference for curl. It's not giving us directly a float, it's giving us a vector 2. So we have x and y coordinate. Let's use the x1. Let's give it a try. FBM, we already tried it. We have C noise. It wasn't a great effect so far. Let's increase the repeat. Now we have the nice noise. We will fine tune it even further later. We have whirly. It's giving us some bubble, but I think if it's at 1, the effect is slightly different. Okay, and we have the curl. Let's change, and we have that nice effect. Let's increase a bit the speed. Let's give it a try. And we have that effect here. Okay. If you look at the effect, for example, of FBM, you can see it's a bit blurry. It's a smooth transition between white and black. But us, because we are using the step function, it's either scene 1 or scene 2. Instead, let's change our logic to not use the step function to have a smooth visual effect between the scene 1 and scene 2 based on our effect. To do this, we will create a new uniform. We will name it Smoothness. We need to define its default value here. Let's set it at 0.5. Let's create it in our experience control. So smoothness. By default, we can use 0.2. It's lighter than 0.5. Minimum will be 0 and maximum will be 1. The step will make it precise with 0.0.1. And on change, we apply it to our render material uniforms. Okay, we have everything ready to code the logic inside our fragment shader. We have smoothness. We need to use it inside our code. Let's restructure our code. We have the step function down here. We will do it just before. So % is equal to step of progression. But instead of the step function, which gives us a result between 0 and 1, we will use the smooth step function. It has a start value. We will use progression and an end value between which it will smoothly transition. We'll use progression plus smoothness and our percentage. What it will do is between progression and progression plus the smoothness, it will nicely fade. You can see different examples of what smooth depth does, for example, on Unity, even if it's not the same shader we use. Before the smooth depth value, we have 0. Then the smooth depth value here, it's 1. Between the two, we have a nice transition. And when it's over that value, it will stick to 1. And we have an error because I made a mistake. Smoothness should be a float. Now let's try it. It's looking nice. You can see that smooth effect. We can even increase it. But we have an issue because when I start it, it's jumping directly from here because we are starting from 0 and at 0 it's very neat. We want a real nice fading effect. It's even more noticeable when we use a different effect like sea noise and a higher repeat. If I change, it's jumping at the start and then it fades. But we want the start to be smooth too. For the start, what we can do is to go from progression minus smoothness divided by 2 and progression plus smoothness divided by 2. And because we are using float values, it's 2.0. This is a good starting point, but let's have a look at what we have. If we do the transition, because we are using progression minus smoothness divided by 2, when it's over, we still have a bit of the fade effect. If we increase the smoothness, it's even more visible. So we don't have the transition issue. It's mostly transitioning at the beginning. In the end, we still have the effect here, which looks pretty cool, by the way, but it's not what we want. What we need to do is to adapt the values we have here. So we need to smoothen the progression. We want it to be from 0 to 1. But currently, what we have is we have minus smoothness divided by 2 to 1 plus smoothness divided by 2. And we want it to be smoothened, but to enter between 0 and 1 values based on the progression. To do this, we can use a remap function. It is not a built-in function, but it's a function you can find online, and it's good to know that it exists and you can copy it. So the remap function, it takes your value, the minimum value it can get, and the maximum value it can get, and what minimum value you expect to get out, and the maximum one. It requires the inverse level function to do it, which is also not a built-in function. So let's paste the implementation I found online. And now we can use our remap function because the mix one is a built-in. Let's go back to our smooth step here. We will create a float smoothen progression. It will be equal to a remap of progression. We will use 0.0, 1.0. So our progression can go from 0 to 1. We will remap it into minus uSmoothness divided by 2 and 1 plus uSmoothness divided by 2. So now our smooth step, we will start it from smoothen progression to smoothen progression plus uSmoothness divided by 2. Let's give it a try. If we change the mode, we have that nice and smooth transition, and it's completely over here. So if I change the progression manually at 0.8, we can see here it's smoothened until the end. And if I go close to the beginning, it's nicely starting here. But when I'm at 0 or when I'm at 1, it's not visible. And of course, it works for a lot of different effects. So for FBM, we can increase the repeat, lower the speed, change it, and the effect is very different based on the smoothness you use. So here you can see it's fading nicely, while if you don't use a smoothness, it's very abrupt, like at the beginning. Of course, it's nice to do transitions using shader and to go from one scene to another one. But what you can do to enhance the experience is also to animate maybe the background of the scene or to animate the camera position while the transition is playing to give more life to that transition. Thank you for watching. I hope you enjoyed this video. If it's the case, please hit the like button, as it really helps the channel be more visible to other creative developers. Don't forget to subscribe to not miss my upcoming video tutorials. And if you want to continue learning how to build 3D website, I recommend this video here.